This how-to video is again related to acid bases and buffers worksheet 1, and this one is question 1M, which is written down here. And I've also extracted from the question sheet other important information about benzoic acid, its molar mass and its acid dissociation constant, which will be required to answer this question. So the first part of this question then, we've got 1.56 grams of benzoic acid and it's dissolved in 400 centimetres cubed of water. So the first stage of this question is to work out the concentration in moles per decimetre cubed, and we do that like this. So there we go. We've got the number of moles equals the mass over the molar mass. So we've got 156 grams divided by the molar mass, which is 122, which gives us 0.0128 moles, and that is in 400 centimetres cubed of water. So the moles per decimetre cubed is the number of moles times 1000 divided by 400. And if we do that calculation, we get a final concentration of benzoic acid of 0.032 moles per decimetre cubed. Now what else do we need to know about benzoic acid? Well, it's given away in the question really. We've got an acid dissociation constant here, which tends to indicate that benzoic acid is indeed a weak acid. So we cannot assume 100% dissociation, it only partially dissociates. So in this case, we now need to use a different formula, which is this. So this is our weak acid equation. We've got our hydrogen ions, square root of the acid dissociation constant times the concentration of the weak acid. And if we remember, we assume that the concentration of the weak acid is given to us here. We're assuming that there is no dissociation, or the amount of dissociation is so minimal that the concentration of HA, the weak acid, is the same even after it's slightly dissociated to form hydrogen ions and A minus ions effectively. So, and now it's simply a matter of plugging in the values and arriving at a hydrogen ion concentration. So let's do that. So there we have it with the numbers put into the equation. We've got our acid dissociation constant, which we've given up here. We've got our concentration of HA, which is here. We multiply these two numbers together and we square root that value, and we get a hydrogen ion concentration of 1.42 times 10 to the minus 3 mole per decimetre cubed. And then it's plain sailing from there. All we now need to do is to do minus log of 1.42 times 10 to the minus 3 to work out the pH. So let's quickly do that. And here is our final answer. pH minus log 1.42 times 10 to the minus 3 is 2.85. So in summary, the pH of 1.56 grams of benzoic acid dissolved in 400 centimetres cubed of water is 2.85. Once again, I hope that helps. Thanks.